If you're trying to apply complex or sinusoidal loads, DLOAD isn't just capable, it's surprisingly easy. In this video, I'm walking through two simple examples that show exactly how it works. I also compared the results with analytical field expressions. They matched almost perfectly. If you've been avoiding subroutines, this will change the way you think about them. Let's get started. Alright, as usual, we start with creating part. Create part, 3D deformable solid extrusion, continue. Then we create a rectangle, just like this, and adding the dimensions. This can be 5, this can be 50, scroll button, and this can be 40, and this is the plate we have. Now let's go to the materials properties. We create a property, mechanical elasticity and elastic, 210 E3, 0.3. Okay, then we need to create a section, solid homogeneous. Continue. Okay, now we need to assign the section. Here, done. As it turns green, it means the property is assigned. Okay, let's go to assembly, independent, and okay. Then we need to translate it. I translate this one to here and done. Then reset the view and we're done with the assembly. Let's go to the step. We want to create a simple step, static general, and yeah, we accept the defaults, and we can go to the load and boundary condition. From here I want to create a boundary condition. It can be in step initial, symmetry, continue. I rotate the sample and select this one, done, in Casr. And okay, as you see, it is in Casr. So I want to reset the view once more, and here we create the load. This should be on step 1, and we can use pressure. Continue, select this surface, and okay. And here we can use the user defined. I put the magnitude on 1 because we're going to write the code in the subroutine. Right, the load is over. Let's go to the mesh. Let's see the edges. By holding shift, we can select these edges and done. I put it on by number and 5. Then I generate the mesh and it is good. Now we need to go to the job and creating a job. Create a job. I name it DLOAD 1, continue, and here we need the subroutine file. Okay, let's open Abaqus documentation. In the start I click here, and happy World Donkey Day, by the way. And yeah, we go to the Abaqus documentation. It redirects us to the website. From here we go all the way down to the user subroutines, and here we have Abaqus standard subroutine. We can either choose it from here or here. We go to the DLOAD and we need to copy and paste this one. So I copy here. Okay, before going to the Visual Studio, let's see what the variables are. We have kstep, which is the step number. We have kinc, increment number. Time 1 is the current value of the step time, and time 2 is the total time, which is the step we have in the Abaqus, and null is element number, and you can go ahead and read it yourself. Alright, let's open the Visual Studio 2022, and here I would go with continue without code and file, new, and file, Intel Fortran, and we need to select Fortran fixed form.4. Okay, let's paste it here. This should be blue. If it's like this, the code would not work. By hitting tab, you can create the indents. Okay, we need to have the code here. First, let's define x, which is chord 1, and y is chord 2, and z is chord 3. And here we need to define f, which is 5 times x plus 2 times y. This is the load we want to have. It cannot be input in the Abaqus easily, so we need a subroutine to do that. Okay, let's save the file. Hit the Ctrl S and choose the folder. I would like to name it DLOAD1 and save. Now from Abaqus we select this, we go here and DLOAD1, okay, and okay, then you submit the job. And yeah, as you see, it is completed. Let's go and take a look at the results. Yeah, it is applied as we wanted. There's another way which is way easier than writing subroutine, which is going to here. Instead of using the user defined, we can have the analytical field, continue, and here we have x. We can say x times 5. We can use parentheses here, plus y times 2, and continue. Here the magnitude can be 1 because we already used that in the analytical field. And okay, now as you see, we have the load distribution. It's actually a better visualization, and if you look at it right like this, you see we have the load here. It's not that high here, and it goes like higher here. It's more understandable and easier to apply. So let's go and create another job and see how it goes. Okay, let's say analytical field 1, continue, and we don't need to use this user subroutine file, and submit. Monitor. The input is completed and the job is also completed. Let's go and take a look at the results. And as you see, the load is exactly the same. Let's compare them. From here, let's create a viewport. Now from viewport, we can tile horizontally. Now we need to choose the other one here, maybe DLOAD for this one. And as you see here, this one is DLOAD1 and this one is analytical field, and the numbers are the same, the contours are the same, and everything else is the same. Okay, now we can go and create the second example. Let's close this one here, and we can change the load here. Let's create a sinusoidal load. But before writing the syntax, I want to ask you a favor. If you enjoyed this video so far, please tell me your feedback in the comments down below. It's totally free for you, but it motivates me to create more videos like this. Okay, now let's change it. I would like to put 100 here times sine, open the parentheses, 3.14 times x over 50. So this is a sinusoidal load and we want to save that. So from file and save it as DLOAD2. Now let's go to Abaqus to create a new job. Create DLOAD2, continue, general, the user subroutine must be DLOAD 2. Okay. Now submit the job. And the job is completed. Let's go take a look at the results. Yeah, this is the load we have. Now let's go and do the same thing with analytical field. Okay, from here we double click and we create a new one, maybe number 2, continue, and here we can have sine function. Here this is sine 3.14 times x over 50, and okay. Now we change it to analytical field 2, and we can have the magnitude here 100, and as you see the load is created. So here we can see the distribution better, and let's go and create a job. Analytical field, maybe sine, and okay, submit, and it is finished. Let's go take a look at the results, and it is exactly the same. If we create another one here, and from view dial horizontally, we can have the analytical fields here, and here we can have the DLOAD 2. The values are the same and the contours look the same. And that's it. If you enjoyed this video, smash the like button and subscribe to the channel to see more videos like this. If you want to learn DLOAD subroutine, click on the video on screen before it ends. Stay tuned.